Hello guys, I'm Yasir Ali. Here in this tutorial we'll discuss that how to calculate friction pressure loss in a coil tubing using Cerberus software, which is a modeling software for coil tubing. We know that the friction pressure is very much important, that because it is used in all our hydraulic calculations and hydraulic designing. So let's see that how to calculate this pressure loss with the help of Cerberus. So first of all, we'll double click on this Cerberus icon and the home page of the software will be opened. Okay, so this is the home page of the Cerberus software. After that, what we'll do, we'll select the Hydra module, because this frictional losses, as I mentioned, is useful for the hydraulic calculations. So of course this friction pressure loss will be the part of Hydra. That is, Hydra module will be the section where we can use this where we can calculate this pressure loss, that is friction pressure loss. So we'll double click on this Hydra module and Hydra module will be opened. So this is the Hydra interface. It is written that welcome to the Hydra wellbore hydraulic simulator. Use this program to model the circulation of liquids, gases and multi-phase fluids in the pipe, wellbore and reservoir. Time being, because we have to just calculate the friction pressure loss, so we no need to go into the detail of Hydra. We'll just focus on that how to calculate this friction pressure loss. So for that we no need to discuss this particular section. We will see when we will discuss Hydra module separately. So just for our main target, that is to calculate friction pressure loss, we will go to the utilities section. Okay, so here we will go to the utilities section. In the utilities section we have these three options: fluid flow, reservoir flow and nitrogen calculations. So we'll click on this fluid flow option. Okay, so when we click on this fluid flow option, so we'll end up with this Hydra flow calculator. So this message is written that this utility calculates the pressure drop along a length of pipe or annulus. You can choose any fluid type or can control all the parameters which are used in Hydra for the pressure drop. That is, we can use any fluid we have to pump, and we can use other parameters for the calculation. This utility allows you to verify each model and observe the effect of each input parameters. However, the calculator does not simulate well conditions, which usually involve circulation and mixing of fluids through pipes of varying dimensions and properties. Use the main screen to perform calculations for a single set of conditions. Use the pressure analysis feature to plot graphs for a range of flow rates in order to observe trends. Anyway, we'll just click on this proceed to calculator button, and this window will open. This is basically fluid flow calculator window, which is used for the calculation of pressure drop in a coil tubing. So it is written that this is the main screen used to calculate pressure drop in coil tubing. The window which will appear at first by default is shown over here. So when we will click that calculator, this window will appear over here. This is the by default window, that is, these parameters are by default. There are three sections in this window, that is the fluid property, pipe geometry and the results. So we have to change these parameters as per our requirement, and then we will get the results. So number one, we'll see the fluid, we'll check the fluid. So from this database we'll check the fluid. For example, we are using the water, so we'll check the model, that is Newtonian fluid, its density and viscosity. Then we'll come to the pipe geometry. Okay, so fluid selection, we see that we have seen that we will select the fluid, and then we'll come to the pipe geometry. So because now we are working for the coil tubing, so we'll select this checkbox, pipe on the rail. By default it will not be checked because we are performing calculation for coil tubing, so we have to check this button. When we will check this button, you will see that this interface will be changed. See, so we have, when we check this button, so other buttons have been dimmed. So now we need these three parameters, that is the tubing diameter, that is ID of the pipe, how much length of the coil tubing pipe, and what is the roughness, temperature, and here calculate input pressure or output pressure. Input pressure means the pump pressure, and output pressure, that the pressure which will be at the nozzle, at the open end. Right now we need to calculate friction pressure losses, so we are interested in input pressure, so we'll select that. We have to calculate input pressure, and we have to provide output pressure and liquid flow rate. These are the just model parameters, so we no need to play with these one. So segments 10, modification factor 1. Yes, core diameter depend upon the reel size. So the reel I am using over for this calculation is 78 inch core diameter. So here we are using the ID of the pipe, that is 1.65. it is basically 2 inch pipe with 0.175 inch wall thickness. So length is 20,000, roughness is in build value, that is 0.002 inch. Surface temperature 80 degree Fahrenheit, and we have selected input pressure, that is we have to calculate input pressure. So what is the output pressure, that is what is the pressure against the open end. So time being our coil is on the surface, so it is 0. Liquid flow rate is 21 GPM, gallon per minute, that is 0.5 barrel per minute. So in this way we will select, and when we will click this calculate button, we will get the input pressure, that is pump pressure, which is 299 psi. Okay, now we'll change the flow rate and see the pressure values. So now we have increased the pump rate to 1 barrel per minute, that is 42 gallon per minute. So 42 gallon per minute. So pressure loss has been increased, because the pressure loss is a direct function of flow rate. So it has become 1121. Before it was like 300, 299 like 300. Now it becomes approximately 1100. So now we have increased the pressure rate to 1.5 barrel per minute, that is 63 GPM. Pressure drop has also been increased to 2400. Now we have make the flow rate 2 barrel per minute, that is 84. So the pressure drop has become 4284. So in this way we can play with the length of the pipe, that is if we have different length we can change the length and click calculate, we will get the pressure. If we have different size of coil tubing, that is different ID, so we'll change over here. Roughness will be almost same, and output pressure, I mean if we are inside the well bore, and the pressure which is at the nozzle, that is hydrostatic, so then we can put that value over here. So in this way we can calculate the pressure drop through the coil tubing. For the fluids, how to model a fluid we will discuss separately in a fluid editor section, but for time being you just assume that the fluid which you are going to pump is available in this particular section. So you just have to select the fluid type, that it is liquid, gas, Newtonian, not Newtonian, and its density, what is the density, what is the viscosity, because this density and viscosity will also affect the pressure drop. So if we just enlist that what are the factors which affect the pressure drop in a coil tubing, it is the fluid nature, that is its density, viscosity, then the diameter, more the diameter lesser the pressure drop, and then the length of the pipe, the roughness, and output pressure, flow rate. So these factors affect the pressure drop in a pipe. So in this way we can calculate the pressure drop through a coil tubing using Cerberus software. I'm very much hopeful that you got understanding regarding what we have discussed. So if you have any question you can ask me in the comment section. Thank you very much for watching. See you in the next tutorial.